First, it's a good idea to make an organized project folder to hold all the stuff we'll be working on. On my desktop, I'm going to make a folder called Computer Project. Inside that folder, I'm going to make another folder just for this computer board named TCPU 816. And finally, inside of the TCPU 816 folder, I'm going to make another folder just to hold this Logisim project. Now in Logisim, I'm going to make a new project and immediately save it to the Logisim folder we just made. And now your project folder should look something like this. At this point, we have the beginnings of our project. Let's first start off making a simple module we're going to use all throughout the circuit. The ALU will need to contain a hold register to store the results of an operation. The hold register will perform double duty as it will also serve as the B-side input of the ALU. This register is a core component of the ALU, and our Logisim model won't function properly without it in place. So let's begin by creating this register module. First, I'm going to go to the design table on the left, right-click on the TCPU 816 name and click Add Circuit. And we're going to name this circuit reg_chip. This will create a subcircuit with the same name under our design table. We're going to start out this project by creating a generic register chip module and assigning it the input and output pins it needs. Now, Logisim already contains a register in the default parts table, but we're going to be making this custom register component that matches the behavior of the physical hardware. This is something we'll be doing a few times during this project so we can make sure our simulation matches the hardware as closely as possible. So go ahead and double click on the reg file subcircuit name and make sure you have it selected in the title bar. First, we'll start by placing a register component from the parts list. Next, we're going to go to the wiring tool and select pin. What we'll do now is create a labeled pin that will serve as the interface of our subcircuit. Make the input 8 bits wide. Now click where it says required for HDL and enter in the label name D_in, and note that spaces aren't allowed in labels. Next, place another single bit pin below the first one and connect it to both the clock and write enable pins of the register. Name this pin CLK. Now add another single bit pin and name it N_reset. Lowercase n underscore prefix will represent a active low pin. Add an inverter from the gates menu between the pin we just placed and the reset pin of the register. Then connect them all together. Finally, add another 8-bit wide pin, rotating it using the R key, R for Romeo. In Properties, make this an output and give it the name D_out. Now go up to File in the menu bar and save the project. Double-click on Main to go back to the main project page. Then click once on the reg chip module and move your cursor back to the diagram window. And what we have here is the register module we just created. We can now take this module and insert it into any part of our project, and this will help save us time as well as organize the signals we'll need to manage later on. And trust me, when we get to the point where we need to start routing control signals, we'll need all the help we can get. So the more organized we make things now, the easier it will be for our future selves. But now that we have our register module completed, we can now start constructing the actual ALU. And we'll get started on that in the next video.